This is a week's worth of fruits and vegetables in an average university student's dormitory. By 2050, it is estimated that the planet will have to increase food production by 70% over the same land to feed an estimated population of 9 billion people.
The driest on record.
Dry years.
Bone dry.
The governor ordering the strictest crackdown on water use in the state's history.
Across the region are running on empty.
Historic drought.
As climate change progresses, the areas in which we grow food are becoming drier. Not all the areas, but many of them. Maybe take California, for example. They're about to enter, almost a decade of drought. And they provide much of the food for North America, certainly for the United States and this part of Canada. How can we make crop lines that will be more tolerant to drought? Because drought is a reality.
Recent research gives insight into how we might be able to cope with today's agricultural challenges. Luke Busta, a graduate student in University of British Columbia's Department of Botany, currently studies the wax composition of moss.
If it's getting really hot out and they're being concerned about getting dried up, they synthesize waxes, and these prevent them or help prevent them from drying up and shriveling. As it gets drier and drier there, it becomes important for us to understand not only the general principles of how plants deal chemically with responding to drought, but also the details of those processes, because we're going to need to do something about that if we're going to want to keep growing food, I guess. So if you've ever worn a raincoat outside, whether it's raining or not, one major problem with raincoats is when you start walking around and moving, your body generates water in the form of sweat. And oftentimes this is always beating up on the inside of your raincoat, and then your raincoat is wet inside, and if it's raining, also on the outside. But your raincoat is made out of a hydrophobic material that's meant to prevent water from coming in, but also, because our raincoat technology is not amazing, it also happens to prevent most of the time water from going out as well. And this is what plants use their hydrophobic coating for, is the same, the problem that we have with our raincoats is what they're trying to do to prevent water from leaving their organs when the sun comes out. And so they synthesize basically a layer of oil-like molecules, and the water is not able to pass through this barrier because of the chemistry of these two compounds, the water and the oil layer. These are surfaces where water really beads up and kind of rolls off, or when you wax your car, for example, if you drive in the rain, the water kind of beads up and rolls off. So those types of surfaces are often called biomimetic or bio-inspired, both on a chemical level, so what types of chemical compounds do the plants need to cover themselves with to prevent being dried out, and also on a genetic level. So what types of genes do the plants use to make the machinery that makes these chemicals to keep them from drying out? Both of these two pieces of information can be used to either grow our crops in a better way simply through the decisions that we make about how to grow our crops, where to grow them, when to water them, when to do X, Y, Z, and also potentially to engineer better crops.
Improving agriculture to keep up with growing populations while experiencing the consequences of global warming is a major challenge. Understanding wax components on land plants can help not only make decisions about how to grow crops, but also potentially to engineer better crops. This way, university students can continue having their week's worth of fruits and vegetables.